Okay, in this video, we're just going to do problem number 6. So, on the test review for the rational functions. And I may do an example of number 9. I'm not going to do exactly number 9. I may change the numbers and do an example of number 9. So, in number 6, we're going to go ahead and factor it out. We're going to change this to the numerator's already fully factored. The denominator, you're going to factor it into 3x. If you don't know where I'm getting this, see if you can stop the video, factor this out in this way, and get that. All right. So immediately I'm going to see that I have a whole at x minus 5. So when I use my simplified form, it's going to be, if I were to cross out x minus 5 and x minus 5 on my numerator, I'm going to get 1. And I'm left with 3x minus 1. So this is my simplified equation. This is the equation I'm going to use. And that equation looks very similar to the reciprocal. So that's the form that we like, which is good. So number 1, our x-intercepts. So what are our x-intercepts? Well, we have to put our numerator equal to 0. Well, I can't. 1 does not equal 0, so there are no x-intercepts. Number 3, vertical asymptote. Again, we're going to set our denominator equal to 0. This is our denominator. This is our numerator. So my denominator is 3x minus 1 equals 0. And I'm going to get 3x equals 1. X is going to equal to 1/3. Oh my goodness, it's a fraction. Is that okay? Of course it is. Of course it is. X can equal 1/3. We're perfectly fine with that. We're no longer afraid of fractions. So I'm going to have a vertical line at 1/3, which is going to be really close, but not quite on the y-axis. Not quite on the y-axis. So my horizontal asymptote, again, since this is in reciprocal form, what is my k value? My k value is 0. So we've got a horizontal asymptote at 0. We like that. We like this form. So my horizontal asymptote is where y equals 0. Another way that you can do this is you can go back to the original equation and say, is it bigger on top? Is it bigger on the bottom? It is bigger on the bottom. So another way you could say is bigger on bottom, y equals 0. It works both ways. So if you're married to one way, then that's okay. Bigger on this one, you can still go back to your original function and say bigger on bottom is 0. But now let's deal with this whole. So we've got a whole at x minus 5. So we're going to set that equal to 0. So x is going to equal 5. And again, since we're looking for a point, I need both an x-coordinate and a y-coordinate. I found my x-coordinate at 5. But in this equation, what is y when x equals 5? Well, let's see. Y is going to equal 1 over 3 times, we're putting in 5 for x, minus 1. And I'm going to get y equals 1 over 3 times 5 is 15 minus 1, 14. Oh my gosh, another fraction. Is that okay? Yes, it's okay. 1/14. Yay. So my whole is going to be at 1, 2, 3, 4, 5, and just 1/14, which will be just above the x-axis. And I forgot to graph my horizontal asymptote at y equals 0. So my domain is basically going to be where x is all real numbers, where x cannot equal 1/3 and x cannot equal 5. We're okay with that. And my range is going to be where y is the set of all real numbers, where y cannot equal 0 and y cannot equal 1/14. So what is that going to look like on a graph? Again, you can start plugging in numbers into x and y and figure it out. I'm just going to plug this into my calculator real quick and do y equals, I'm going to use my parentheses, x minus 5 divided by, oops, I didn't mean to do that, divided by parentheses 3x squared minus 16x plus 5 in parentheses, and let's graph that and see what that looks like. And that is very, very close to both axes. So I'm going to just kind of see if there's a point I can pull off of here. And at 0, -1, 0, -1, there's a point. And let's see if there is not even a whole number, but there is an error at 5, which is great because that's where my hole is. And I'm just going to go ahead and plot at 1 1/2. So really my graph should look more like this. I'm going to be looking for you to graph at least one point on both sides. So it is very close to those x-axes, or the x and y-axis. Alright, so there's that. Now let's just talk quickly about numbers 9 and 10. If you were going to work on this, I'm not going to tell you the answer, but if I were to have a rational function with an x-intercept at, say, 8, 0, and a vertical asymptote at x equals 2, and a hole located at 3, at x equals 3, let's just say x equals 3, there's a hole where x equals 3. How would I do this? So this is going to be my vertical asymptote. This is my x-intercept. How would I write that equation? Well, you basically just figure out, what do you know? You know that to find your x-intercepts, your numerator has to equal 0. So x minus 8 will give you a numerator of 0. So that's my numerator, because that is my x-intercept. I also know that my denominator, because this is my numerator, equals 0 at my x-intercepts. My denominator to create this vertical asymptote cannot equal 2. So that would be x minus 2. And if I have to have a hole at 3, if I have x minus 3 over x minus 3, will that create a hole? You bet it will. So there is your equation, where your rational function has an x-intercept at 8, 0. Your vertical asymptote is at x equals 2, and you have a hole located at 3. Now the question is, so let's just see, what would the whole y be? 3 what? Well, let's see. 3 minus 8 divided by 3 minus 2. That's going to be -5 over 1. So the y value would be -5. There's your hole. All right, hope this helped. See you guys on Tuesday.